Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone and welcome to the third part of neural network series in machine learning with scikit-learn, and this is the third part of the video. And in the previous videos we looked at the concepts of the neural networks and how they work, followed by the terminologies which are necessary to understand and work with artificial neural networks, followed by a sample code of a very basic neural network. Now let's move forward with this video and see how a neural network can be implemented in scikit-learn. So here's our notebook ready, and this is the link which scikit-learn provides for the neural networks or the neural network models present inside scikit-learn. Now neural networks are mostly supervised learning. People do get confused a lot with understanding neural networks as unsupervised learning, but for specific cases of neural networks, those are unsupervised learning. For example, Boltzmann machines. Okay, so scikit-learn provides the neural network without the GPU integration, and this is the reference and the same thing scikit-learn has explained for the working of different layer of neural networks, and the complete documentation is being provided. As you can see, the complexity and the mathematical functions that we can understand, including the loss functions of how does it works and how does it iterate time. Very useful. So let's look at a very basic implementation code at the first. Okay, so we will be calling a MLP classifier. So MLP stands for multi-layered perceptron, or a normal neural network is also known as a multi-layer perceptron. So simply means having a multiple layers of perceptrons is the neuron that works, and inside that we have the classifier, so it classifies for the given data, and it's present inside the neural network subclass of scikit-learn library. Now followed by that, when we see as x as the two values that we are taking, as if the input is 0 0, for the corresponding y value will be having as 0. If the value is 1 and 1, it will be having the value 1. So that is the input that we have, followed by we call the instance of the class, making the MLP classifier and giving the necessary inputs for that. And as we can see, this is the two main inputs that we need to take, that is the hidden layer sizes of the 5 neurons followed by 2 layers and a random state of 1. And random state and seeding are the same concepts, called as a random state in scikit-learn and major machine learning libraries. So once we have the instance of the class made, what we'll do is simply make it learn for the given input of, if it's having same bytes of data or anything like less than 1 or the pattern that it derives to, it will be able to understand the concepts by itself. Now one thing that one cannot always make a neural network do is to understand the concept everything by the one user wants it to do. So once that is done, we'll try to predict what will be the output that we'll be getting for 2,2 and the bits are of lesser than 0 or 0. So let's try to execute the code, and we can see that when the values are greater than 0, we are able to get an output of 1, and the values when are 0 less than 0, we can simply see we got the output as 0. Now as you can refer from the previous video, we were specifically running it for a certain number of times. In this one, scikit-learn allows you to save that practice and runs it till the time it gets the optimized results. Now that's a very basic idea of implementing a neural network with scikit-learn, and it comes with the MLP classifier. Okay, so let's move on and look at to one of the other example of using scikit-learn's neural network in a live case. As you can see, this is a given code provided for an artificial multi-layer perceptron, and the data is taken as a heart disease prediction data, in which the user needs to predict whether on a given instances the person will be having a heart attack or not. So as we can see in the dimension, the input nodes are 9. The number of input nodes will depend on how many features you are providing to the neural network. Hidden layers are 2, and each hidden layer contains 14 neurons, followed by the number of output layers. Now the output layers are defined in the classifier of how many outputs the user needs. For example, if it's 1 0 or the binary, it usually is 2 output layers. So we call the neural network in this specific line as MLP classifier, and we call the instance. Now what happens is, here we have passed the number of libraries that the dictionary as a dictionary, then specific parameters which are being needed to give into that. So once that is done, we set the hidden sizes or the hidden layers as the same, followed by the random states that we are having. Once that is done, the instance has been made, the best fit is being taken. So simply passing off the X train and the Y train data, and as we can see, the activation gets reload. It automatically sets the learning rate and sets everything by itself, so that you can work on the progressive side as compared to converting each and every value. And when it runs that, we are able to get the specific predictions in the instance of predicted values of X test. And as we can see in this specific data, this is the learning rate, and is able to obtain an accuracy of 76%, a recall of 86%, and a precision of 73%. Okay, so what that means is, the data, even if it's a very less in size, the neural network can understand it very much easily and is able to draw patterns as much as possible. Now it's usually preferred that the more amount of data that you feed to your neural network, more it will be able to understand that. That is one of the drawbacks that we need to look into artificial neural network, including that it takes a very high computation as compared to the other algorithms in machine learning. So that was about the artificial neural networks and scikit-learn, and I hope you enjoyed it. Thank you.